This lesson is about color. Each color in Java is defined in the form of a color object. The color object uses what is known as the RGB format. That is, a color is defined as a mixture of the relative intensities of the three colors red, green, and blue. Now in school we were taught that the three primary colors are red, blue, and yellow. And that's true for pigment, but the primary colors of light are different because of what happens when you mix them. Pigment colors are said to be subtractive and light colors are additive. It's easiest to remember it this way. When you mix all three primary colors together with paint, you get black. When you mix all three primary colors together with light, you get white. So not only are the primary colors different, the way you mix them is different. It's this difference that causes a lot of confusion with graphics software. When you print something, it will show up in one color on the screen and another on the page. That's because the translation from one color model to another, and it isn't always as smooth a translation as you'd like it to be. But that's not the problem we're trying to solve here. We're just dealing with painting colors on the screen with Java. Java includes a small collection of predefined colors that you can use to paint things. This may look a bit odd at first, but it does make sense. When they decided to create some color objects as part of the standard API, they had to put them in a class because everything in Java is inside some class or other. They wanted to put them someplace so everybody could remember where they are. So it seemed the most logical place would be inside the color class. And here they are. They appear as data items inside the definition of the color class. Each one appears twice, once in lowercase and once in uppercase. They're the same no matter which case they're in. It's just done this way for convenience and personal preference. Let's take a look at one of them. The colors are all declared as static, which means that only one copy of each one exists. That is, there is only one copy of this object, no matter how many objects of this class are created. It's public, so it can be directly accessed from outside the class. It's also declared as final, which means it can't be changed. And of course, it's a color object that bears the name of the color it contains. Let me show you how they can be used. Looking back at the code of an example from the previous lesson, this canvas uses two colors from the color class. The one named pink is used to specify the default background fill color for the entire window, and the one named blue is used to store into the graphics object so the rectangular area then is filled with that color. And here's what it looks like. Notice that whatever size the window is set to, the background color fills it. Now, here's another way to fill this window. Now, this version doesn't set a background color. Instead, the paint method fills the entire window with the color, then draws the square on top of that. But there's a drawback. Look at this. The background doesn't change to fill the window. If the paint method could somehow know the size of the window, it could adjust the measurements used to the calls to fill rect to match whatever the window size happens to be. Now here's a canvas that does that. The paint method makes a call to getBounds. The getBounds method of the canvas returns a rectangle object that contains the height and width of the window. This call is made at the top of the paint method, so it'll get a new rectangle object every time the paint method is called. And the paint method is called every time the window changes size or is exposed or whatever. The first call to fill rect uses the height and width of the window to fill the entire area with cyan. The second call to fill rect uses the size of the window to insert a rectangular area into the center of the window. The inserted rectangle will always be 50 pixels from the edge all the way around. This is achieved by placing the upper left-hand corner 50 pixels over from the left and 50 pixels down from the top, and then adjusting the width and height 100 pixels less than the width and height of the window. It looks like this.